Hi, everyone. Nice to meet you. So CloudBank Classroom has been around for a little while, but it's expanding greatly in scope. The idea of CloudBank is making commercial cloud available for researchers in the way that the NSF makes like supercomputers available. And then Classroom was a small sub-project of that, where we had you've been using the cloud for teaching at UC Berkeley. And then we had, a whole open source project, open source nesting suite of tools that was able to deliver interactive computing for data science classes at quite a large scale. And we started CloudBank Classroom as a way to get that out there to other universities. And we did a bunch of work with community colleges, HBCUs, and now it's generally open in CloudBank 2 and the renewal of CloudBank for anybody. So I'm Eric. Here's my email. If you want to follow up, I'm happy to like take a call with anybody and talk about data science curriculum, AI curriculum, or just CloudBank Classroom generally. I have a colleague, Sean Morris. I didn't have his contact on here, but he is like the engineer who will set you up if you go and request a version of this for your institution. What I'm going to talk about generally is just give an overview of what CloudBank Classroom is and some of the practicality there, and then just about using JupyterHub for teaching. So how to get a JupyterHub from CloudBank for teaching, and how to use JupyterHub to make an easy on-ramp for students, and sort of our opinionated choices of open source tools for teaching. Who am I? I'm Eric. I am not a CS professor. I am not an AI professor. I'm a lecturer at UC Berkeley, and I teach at in the overlap of data science and economics. So I built a couple classes of my own using this platform of open source tools, Data 88E, Econ 148. If you know anybody out there who's interested in econ and data science, I'd love to meet them. I also teach a data science honors thesis class that has like a lot of like reproducibility and science, open science approaches in it. I have a staff job for UC Berkeley where I do outreach for data science undergraduate studies. I do community building in the data science space, help with statewide coordination of curriculum. So if you're interested in data science curriculum and higher ed, I also host a workshop every June where I get people together that are interested in data science education. So a lot of it's about sharing and outreach on the open source framework for teaching. And from there, I'm sort of a Jupyter in the classroom evangelist. Like I've spent many, many years doing curriculum development across campus, getting people from many different disciplines to teach and learn with Jupyter. And I have helped the campus we've had like 10 years of having this JupyterHub at scale for all at UC Berkeley and teaching teachers. So a lot of the agent of change in my life is like getting teachers familiar, interested, engaged with, this interactive computing in the classroom. And something that I do a lot is like professional development workshops on teaching with Jupyter. Hence, we are here today. I am not an AI person, so there's a lot of like how to teach AI right now. I have been on a side quest to figure out how to teach AI in Jupyter, and I will kind of just touch on that during this shorter talk. But if anybody wants to engage or talk about that, I have made a lot of, excuse me, success in sort of thinking about what it's going to be like to teach AI in Jupyter going forward, and bringing to bear some ideas that I have about how the infrastructure, how the platform of interactive computing, and how we can build around that into this AI space. But I'm, yeah. So For the NARE, National AI Research Resource, and for Access, there's a lot of interest in like what's going to happen in an AI classroom. What will an AI classroom look like? And I have been trying to, distill what we have from the Jupyter for Education work. So I've been on a side quest building this idea of having small open weight models that open in JupyterHub. There's a lot of what we do for teaching with JupyterHub where we like sort of set up the framework so it's really easy for students, right? So the student doesn't, even just for a data science class, the student doesn't have to do Conda, they don't have to do command line, they don't have to do GitHub, they don't do anything. They just like click a link and this environment pops open that has everything they need to start doing data science. So some of it's like, can we do this similar thing for using these open weight models? The next, and this is a very big topic right now, is how to get GPUs into a classroom. What if you wanted all of your students to be able to do some assignments using GPU? And so we've been sort of experimenting and piloting, building JupyterHub with GPU. And we will have like instructors trying that out in the classroom. We've mostly been trying that sort of in workshop demo mode. Um, and something that we will keep building towards. So it's a collaboration. I'm at UC Berkeley. CloudBank is hosted at UC San Diego. We work with a nonprofit called 2i2c, who is really big in this like open infrastructure space. Really good partners to talk to if your institution wants to have something in the JupyterHub space. Would definitely refer you to 2i2c to go beyond with just what CloudBank Classroom can offer you. And we are part of NARE Classroom Pilot and Access, and I'll talk about those a little bit. So there is a workshop hub. I probably won't have time to open it or log into it, but if you want, also with more time do some demos for NARE that you can log into a CPU hub or a GPU hub. So the two things that you can see on this picture are like we have, a CPU hub with this environment or a GPU hub where you have a shared GPU, two people per GPU in a shared environment. And then this funny meme on the right, the logo, this was my side quest, hugging face inside a llama, inside a Jupyter. So that is sort of like what I'm trying to develop recently in this, like, what is the AI classroom going to be like? All right. So why are my slides keep jumping around? You know, where I am, with teachers and professional development, I want teachers to have some familiarity with Python or some ability to just take on learning a little bit of Python. Totally works for R as well. So at least like some knowledge of R, and we will teach them the rest of the tools that they need. It can be, and it had many times, interactive computing is just modules in an existing class, right? So I can be, an existing class, here's an existing Python class, but something, where I can like put a little bit of a AI or a little bit of machine learning into a class. And then a lot of the design parameters are about using a full stack of OER, making our notebooks available so that other teachers can use them, and not being dependent on a single vendor. Like the notebook should be able to open anywhere in the world, right? And so some of the things that have influenced me that I've learned over from the Jupyter folks, open source matters, public infrastructure matters. We're here as a resource provider making public infrastructure for you. One of the guiding things is democratizing access matters, right? So can we make it easy for new learners to get online? And then I would say now in the AI world, understanding the algorithm matters. Can we build interactive computing in ways that get students to understand what's going on in the machine learning and AI world? And then another argument that I want to make is that using these Jupyter open source stack tools, we are teaching students with the classroom tool being the same tools that the scientists and researchers use, and scientists and researchers are using for scientific reproducibility. So I also have like, some points that this is a metacognition point, that we teach people the right way. We're giving them, thinking about how modern science is done. All right. Well, jumping back, we are a research provider. We are an NSF grant. We are providing access to small amounts of interactive computing for classroom demos. CloudBank is the thing over us. That's the big NSF grant. And then we are collaborating with a nonprofit partner, 2I2C. And then there's a couple of us at UC Berkeley that are making these classroom applications available. Why? So we started with, could every small classroom at a community college have the same JupyterHub environment that UC Berkeley has? So can we take the steps, put the stack together so that the instructors don't have to roll their own for their own class and they can just focus on teaching? Another is, should it depend on what laptop a kid comes to class with, or if we take over the classroom environment with JupyterHub, it doesn't matter whether you have a Chromebook or an iPad or the most powerful MacBook, right? So there's an equity issue of like students in the classroom should have equal access to good compute. And we have multiple years of access, multiple years of experience providing JupyterHubs to the community colleges and other universities. So we've been doing this for a few years and we know that it works at scale. What's happening under the hood? There's something that's, what the cloud providers have built Kubernetes to make compute spread efficiently across the cloud. We can use those scaling tools to, have the amount of compute that we're using go up and down based on demand. JupyterHub is its own set of software that's providing an IDE in a browser. It's providing authentication. It's providing a small little amount of kernel of contained compute for every student. And then there is a layer above where there's CloudBank, where the government has grants for using the cloud providers, and we can use that to buy the Kubernetes resources that make it available to the classroom. If you're interested, you can sign up by going to the CloudBank webpage, and the links here say for educators. And you can sign up either through NairPilot or through Access. You have to write up a simple little page of saying like what your class is, how many students are in it, what semesters you want to teach. And then that gets forwarded through a ticketing system, and we set that up for you. Onboarding, you go to Access. Access is the portal for accessing all the different amounts of compute from NSF. You request an allocation. If you get the allocation approved, the credits are going to get routed to CloudBank. This step is mostly invisible to the classroom users. We go and we set up a dedicated Kubernetes namespace for your institution. And then we set up so that authentication works with the single sign-on of your university. So the students are just going to go to this URL. They're going to log in with their regular local credentials, and they're not going to know that any of this is happening, right? We're trying to smooth it out for the students. You, as the instructor, you need to do this part where you apply for the access resources, and then basically you need to work with Sean Morris, who's going to set it up for you. You can do the exact same thing through Nair as well. So you can go to NairPilot and request a NairPilot classroom. And remains to be seen, Nair is moving from pilot into an official, I forget what it's called, but resource institution with congressional funding going forward. But we are still there under the NairPilot page. All right, so what do we want to think about as teachers? And this is sort of my point of like, where are we at with data science education? Where are we at with AI education? And one thing that I like to think about is, if you think about data science education potentially as like climbing some sort of ladder of scientific Python, right? So we have this class. This is a lot of the work I do is this intro class, intro data 8 class. Everyone at UC Berkeley can take it. Something like at certain points, something like half of UC Berkeley students were taking this class, right? You come in the door, you are touching NumPy right away. The first day in a Jupyter notebook, right? So you're like little bits of Python, little bits of NumPy in a Jupyter notebook as a freshman in college, right? If some people are like, just needed to take a stats class, I'm going to do, sociology or psychology or something. They may have to take one other class where they go on to do more statistics. If you decide you like data science, you're going to move on to pandas or polars, right? And then from there, data engineering, SQL, and then more advanced to machine learning. So that'd be Python packages like scikit-learn. Upper division, like senior level classes using TensorFlow or PyTorch, right? So these are like the AI and the ML advanced classes. And then there's the side quest stuff that I was working on that's like touching. There is a Python package for a llama that creates the harness for these language models, and you can go to Hugging Face and get the language model and use it in a Pythonic Jupyter way as well. So also want to make this point that I made before that like this is an industry standard tool for data scientists, right? So we're teaching a freshman in their first class to use Jupyter and NumPy, which is a real industry standard tool. So I think that's like an interesting take here. And then also for me as a teacher, in my classes, there's like another Python package, another Python package. Like, and so in my upper division class, I sort of am trying to teach them, hey, it's a new Python package. What are the arguments you need to feed in? How does this relate to the type of data that you're familiar with like a pandas data frame? And is this new package going to create some pandas information for you? Is it going to feed into a visualization package for you? So how does like the existing scientific part of the scientific Python framework that you understand, how is like a new package going to fit into this? And certainly when we learn scikit-learn or TensorFlow, we are seeing like, oh, what do we know so far about scientific Python and how does the next thing fit in? Another thing, learning from is like Jupyter education at scale. So as I said, this data 8 class, 1,500 students per semester, single biggest class at UC Berkeley. And in some ways, it's built as an OER. It's built sort of interesting also as like a software engineering project, right? So the class itself is built with software engineering practices, but it also is a set of Jupyter notebooks, right? There's 12 homework notebooks, there's 10 lab notebooks, there's 3 project notebooks, there's 40 lecture notebooks for in-class demos, and then the textbook itself is stitched together Jupyter notebooks. So when we're sharing this and we're making OER resource out of this, these are like GitHub repos full of notebooks. From there, this premier upper division class, gateway to the major, like the biggest upper division class at UC Berkeley, Data 100. Again, it's following the same system where it's like a set of homework notebooks, a set of lab notebooks, a set of big projects, and lots of demo lecture notebooks that the professor does in class. Again, the course notes are stitched together from sets of notebooks as well. And then on the right column, this is my class. This is me coming in as a lecturer. I want to teach a new class that's going to be like how to teach an economics class. This is my passion, is like how to teach economics using Python, but it's structured the same way. I only have 150 students, but it's still like, I need the scale. I need the tools that work. And I have like a set of lab notebooks, a set of project notebooks, and I'm constantly making up new lecture notebooks all the time. And I have a textbook that's stitched together set of Jupyter notebooks as well. So what are we looking for? Like I do professional development for teachers about teaching data 8 all the time. So we're looking for people that can basically follow a documentation. And then the thing is to manage the curriculum through GitHub. So the students don't have to see GitHub, but we hope that the professor can sort of get this idea of like GitHub is a place that files are managed, and the files that the students are going to use to learn are going to come from GitHub. And that is sort of like our key hope for people learning to teach in this way, because if they're coming from GitHub, it's easy to share the materials. We don't want the professors to have to like build a YAML file to know anything about authentication or the deployments or to have to bug backend anything. And basically, if we can just integrate the JupyterHub with the single sign-on of the university, we don't have the professor for the class do anything about user management either. So here's sort of my map that I'm sort of, trying to explain how this looks. There's a student down here, right? Let's start with the student. The student is just going to open a browser tab. They're going to click on a link from their learning management system or a course website, and they're going to end up in RStudio or JupyterLab and just be doing their interactive computing. The professor's up here, and the professor is sort of managing materials in a GitHub, making links to assignments. Maybe they're doing some auto grading. That's a whole other part of it as well. And then they're making these links we call NB Git puller links, where they just put this link in their, in their LMS that says assignment one. The student clicks the assignment one link, and they just end up in JupyterLab. So somehow behind the scenes, there's this admin side. Let's see if I can move this thing, where there's an administrator, and this is where the CloudBank Classroom, Sean Morris. There's a JupyterHub server that's running. It's got this Kubernetes spawner that's making more compute available as people log in. There's a shared node pool, so users are stacked together inside a node pool. And then there's a certain amount of storage. Like every student gets a small amount of storage where all the files for the semester can live. And there's some authentication between the administration side and the local university. So the student or the professor doesn't really need to know about this behind the scenes stuff. And so there's a lot of like UX here that's like, how can we make it so that the instructor only needs to do the little bit the instructor needs to do, and the student can do the least amount of setup. I will say it's also quite possible to use JupyterHub as a way to teach students a lot about computing and to reveal more and more complexity over time, right? Students could launch from their own GitHub repo. Students could build their own environment file. There's lots of ways to use the sort of ubiquity of the compute and the equality of the compute to teach more and more complicated things. This is sort of the idea, but I'm starting with the idea of like, oh, new student, intro class, I'm going to make it really simple for them to just be in a notebook and doing the work in the notebook that I've set them up to do. The idea here is the instructor, they're going to build those materials, basically folders in a GitHub repo. They're going to use these links to distribute notebooks. They're going to stand in front of the class and do these demo notebooks. Like every day in class, I like open a notebook and do some demo. And then, the instructor's going to have to decide how the students are going to download and submit the notebooks. Do I want them as PDF? Do I want them as executable notebooks? Do I have a grading server or not? Like these are all decisions that each professor is going to have to make as how submission and grading and receiving notebooks will need to go. The admin, like this is what CloudBank Classroom is doing, is like setting up a default image that's going to work for 99% of cases. So there's like the Python package the package list that is in it. There's this Kubernetes spawner that's like, as people log in, make more resources available, and sort of handling the cloud account and the billing. Where like, the hope is if we consolidate lots and lots of users using small amount of cloud, we can efficiently just pay for that cloud through the grants and through CloudBank itself. In the Data 8 class, we also provide like a Canvas shell that has all the assignments and the links and a template repo that you can just copy that repo over and a little bit of grading infrastructure. So those are like, higher layers where we're like adding on other aspects of the open resources that we're sharing. If you're interested in specifically the UC Berkeley classes, so this is like another hat that I wear, there's a newer website that we made up that has like how to share around an intro class called Data 6 that comes before Data 8, and then the main Data 8 sharing. And there's a lot of instructor guides, like how to teach, how to do this, sort of like 0 to Data 8, instructor guide. And then there's a bunch of materials around Data 100 as well. Some of this is what are the packages that your course needs. So this comes up a lot. I would say for me, as somebody who does outreach here, there is a trade-off between I want every possible bell and whistle for my classroom of this like complicated research workflow. Yeah, maybe you do want that, but that is complicated. It might be expensive. And I also have places where I'm like, can you fit the lesson and the learning objective that you want into like an existing platform and existing package list? So I went on a side quest this year trying to get the AI packages, and that was like really expanding what the environment file was. Um, you have to like set up a whole bunch of things ahead of time, so that was quite a learning path for the AI tool set being slightly more complicated. And I should probably wrap up, but I can just touch a little bit on the teaching AI idea, right? So some of what is the further levels of what we need to set up, right? So some of it is the instructor goes to Hugging Face, pulls an open weight model, a DeepSeek, a Kimi, a Gemma, and sets that up into a shared folder. So that's like an additional step that would happen. The instructor would want to put, a couple gigabyte file into that shared folder. Or you could, a lot of it's through API keys. So you can have an account on ChatGPT, an account on Anthropic, account on OpenRouter, and you put that API key into that shared folder so the students can do it. And then you're sort of like building the notebooks that reflect the context of your class. And then can you sort of like figure out how to fit into the memory constraint and the compute constraint that the JupyterHub has? And I think this is possible, but sometimes people are like, I want every student to like fine tune a model, and you're like, sorry, that much compute isn't available. What could you do that students could learn something without doing that much compute? As I said, we have a setup with shared GPU, and the NRP, Jetstream are these other big NSF projects, and they also have ways that you can get students to have access to GPUs. Design parameters, we still want students to be able to enter with not so much setup. We want students to know some Python, some like ways that they're going to do interactive lessons to learn AI, and how can they have like a little bit of GPU they're gonna be able to do some inference steps without using without costing that much. Um, so yeah, this is on my instructor administrator student file. There's now this new area where this instructor is going to Hugging Face, putting some model weights in a shared folder. The administrator could do this as well, probably, or the instructor is going to go get an API key, get some credits, get some tokens from NRP if you want free ones, or from the companies. I sometimes just put money on my own credit card, and if for the teaching case, I can get 100 or 200 students to use just a few tokens at a time through an API key, so it's fine for teaching. Um, yeah. I should probably wrap up, but if anybody want to talk about this stuff, I do have a whole set of notebooks about teaching AI. So a lot of times when I give this talk, this is the sort of the beginning intro talk, and then I go into this like, what's it like to teach elements of LLMs, and using small LMs or API notebooks to do that. So I'm happy to talk about that more. But for today, that's my talk on CloudBank Classroom. And I wanted to open it up for questions if people wanted to talk about